Good morning. Today we're going to be continuing with what we call our excess reagent calculations, and it's going to look very similar to the stoichiometry that we've been doing the last few days. And it's almost going to be a continuation of our limiting reagent problems that we looked at last class. So if you notice at the top of your worksheet, we have some PowerPoint problems like we usually do. And then it says that it's a continuation of the limiting reagent problems. So we're going to be using the same question that we saw on worksheet 4 last time we were together. So our original question, just to jog our memories a little bit, was first we had to balance this equation that we have here, and then the question was, in terms of the limiting reagent question, was when 10 grams of hydrogen combines with 20 grams of oxygen, what is the maximum amount of product in grams of water that will form? So we took both of those givens and we set up two stoichiometry problems, one with each of our givens, and we found out that the 10 grams of hydrogen produced 90 grams of water, and the 20 grams of oxygen produced 22.5 grams of water. So what we noticed was that oxygen, the 20 grams of oxygen, produces the least amount of H2O, which was that 22.5 grams of water. So oxygen was our limiting reactant. We're going to do a continuation of this problem on the next page, which is worksheet 5. So if you notice, our next question here, and like we said, it's going to be a continuation of what we just did, is to calculate the amount of excess reagent that will remain. So in the last problem, we figured out that oxygen was our limiting reactant. We run out of this first, which means that hydrogen is going to be our excess reagent. We're going to have leftover hydrogen after we use up all of our oxygen, because this oxygen is the one that limits our reaction and how much water we can produce. So hydrogen is going to be what we call our excess reagent. So we know that hydrogen is going to be our excess reagent, but we want to know the amount. We want to know how many grams of hydrogen are going to be left over once we use up that 20 grams of oxygen that we started with. So what we're going to have to do here, really just two steps that we're going to follow, and these were written on our PowerPoint that is on our Google Classroom for you to review, but there are really only two steps to calculating our excess reactant. So the first step is going to be to set up a stoichiometry problem. Again, make sure that your equation is balanced, which it is here. We already have our balanced equation. We're going to start a new stoichiometry problem with the limiting reagent that we determined in worksheet 4. And if we look back here, the limiting reagent was that oxygen. And we're going to calculate how much of the other reactant is actually needed to react that 20 grams of water. So in the previous problems on worksheet 4, we took these reactants, hydrogen and oxygen, and figured out how much product we can form. In this excess reagent problem, we're going to take our limiting reagent, which we know is oxygen, and instead of going to grams of water, we're going to go to grams of our other reactant, our excess reactant. So we're going to go ahead and set up our first step with our limiting reagent amount, which was 20 grams of O2. Okay, so from here, we're going to cancel out the grams of O2 to get to moles of O2. So we know oxygen here is made up of 2 oxygen molecules. So our molar mass is just going to be 16 times 2. So that would be 32 grams O2 per 1 mole O2. And then we're going to use our mole ratio that we can see in our balanced chemical equation here to figure out how oxygen and hydrogen are related. So for every 1 mole of oxygen, we will need 2 moles of hydrogen. So we'll put moles of O2 in the denominator here, so moles of O2 can factor out. And then the 2 moles of H2 in our numerator. Just going back a couple steps, grams of O2 also factored out. Okay, so now we're at moles of O2. We want to calculate the amount in grams here. Usually that's what we'll be looking for, the amount in grams of our excess reagent. So once we're at moles of H2, we're going to go one more step to get grams of H2. So we know for every 1 mole of H2, this will be equal to its molar mass of 2 grams, H2. So moles of H2 factor out. If we multiply all this out, so 20 times 1 times 2 times 2, and then divide by this 32 times 1 times 1, we should be left with 2.5 grams of hydrogen were used. So in order to use up all of our limiting reagent, which we know is oxygen, so to use up all those 20 grams of oxygen, we need to use 2.5 grams of hydrogen. So now that we have this amount, this is what's used, we're going to subtract this amount that was used from the amount that we were given in that original problem. So we're going to subtract the actual amount of the reactant that you're given from this, or from that 2.50. So we'll take that 10.0 grams H2 that we started with, right, that we're given, because we know we'll have leftover of this, we'll have excess hydrogen, and subtract the amount of hydrogen that was actually used. So minus that 2.50 grams H2. If we subtract that out, we should find that we're left over 7.50 grams of excess hydrogen. This is what's left over. So when we say to calculate the amount of excess, our final answer here will just be 7.50 grams. So whenever we're working with an excess reagent problem, we always start with the limiting reagent and go to the excess reagent. So it looks very similar to what we did yesterday or the day before. The only difference is instead of going to the product in our final step, we're going to our other reagent. So there is one other practice problem, or two other practice problems down here. But number 2, I'm going to move this down a little bit. Number 2 is going to be a continuation problem from our worksheet 4 as well, kind of similar to how we set it up in that first problem that we did together. And then the last problem is going to be a combination of a limiting reagent problem, and then you'll go on to figure out how much excess reagent will remain at the end of this reaction. So it's kind of putting everything together in that last problem. This answer key will be posted next time that we meet. So try out numbers 2 and 3 on your own. Let me know if you have any questions, and keep up the good work.